what I want to do is we're just going to run through Chapter 5 and Chapter 6's quiz all together. If you feel like filling in the answers as we're going along, that's fine. Just about everybody's turned them in, so I don't mind doing this, but this will be a shortcut for you retaking it and getting a perfect grade on it. Now the point of this is just for me to demonstrate, the answers up here. And that's why I'm going to be doing what I'm just about to do. I'm going to make sure that the questions are not shuffled, because that's always a problem for us. All right, go ahead and open up Chapter 5 if and you want to. I mean, if you made 100% on it, you don't need to do this. Never know why it thinks we're doing French here. All right, question 1. X is equal to 3, y is equal to x plus plus. Now, if the plus plus comes before the x, it means do it first, before anything else happens. If the xx comes after the variable, it means do it last, before anything happens. So if it was plus plus x, then x would immediately be increased to 4, and then 4 would be copied over to y. So the correct answer would be 4. Well, why did you? But that's not the case, and I don't know why I just lost my everything. Really? Oh, there it is. What is this? Get lost. Alrighty. So, since the plus plus follows the variable, that's a postfix increment. It means do it after everything happens. Everything else happens. And so what is that everything else happening? 3 gets copied into y, and then x changes into 4. So the correct answer would actually be 3. Oh, are you going to do that every time? I guess it is. All right. So with that in mind, what is the answer to question 2?
5.
Correct, 5. Yeah. Because it got incremented and then copied across the equal sign. All righty. Assuming this loop was coded correctly, how many times would hello be printed? It's a pre-test loop, so that means it's a while loop. X is 0, go as long as x is less than 10. We could count it out on our fingers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It would print it out 9 times while it counted x up. X would equal from 0 all the way up. Okay, I've said that wrong. See, I've confused myself. If you start at 0 and you go up to 9, then that's actually 10 numbers. And so that's how many times hello would be printed out. And you can prove it to yourself if you got pencil or paper. My counting it on my fingers didn't work. And what's the difference between that question and this question? Or is there any question difference? Did I just ask the same question twice?
No, the next one does the...
Ask if you change while setting to x less than equal to 10.
Yeah. Keep scrolling, you'll see that there.
Oh, okay. If you change the condition to while x is less than or equal to 10, well, it's going to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so it's actually going to repeat it 11 times. Match the loop structure with its type. Well, while loops, the test comes up at the top. Do loops, the test comes at the bottom. So that means a while loop is a pre-test, and a do is a post-test. All right, A is equal to 100. While A is less than 10, is it going to even get to this C out? If this was an if statement, would it get here? No, because 100 is not less than 10. So, not going to print anything. It's going to print it 0 times. That makes sense? If this condition is false, if it's a pretest loop, it can't even get in there to do anything.
I read that question wrong, that's why.
Ah, okay. Alrighty. And now the same kind of thing. A is equal to 100. Now do this stuff. Is it going to get to the C out statement? And it is, because the test doesn't occur until the end. So it's going to print it out once. Because when it hits this condition is not true, so it's going to fall out of the loop. All right, x is 1, less than or equal to 5, x plus plus. Well, if it was from 1 and without the equals, well, we could just count it out, right? 1, 2, 3, 4, 5. That's going to be 5 times. If it was just x less than 5, then it would go up to 1, 2, 3, 4. All right, here we're counting by 2's. Going up to and including 10. 2, 4, 6, 8, 10. I think everybody got these right, or most everybody. Write a loop that will add all the numbers between 1 and 10 and store the result in a variable called total. And there's more than one way to do this. So, we just need to declare a variable called total. It doesn't specify types or even if variables are declared or not, but why not declare a variable? Int total is equal to 0. And then we need a for loop that's going to count from 1 to 10, or a while loop. But for loops are the best, right? Int I is equal to 0, I is less than 10. Well, no, I've already made a huge mistake. I'm going to finish typing it, and then I'm going to correct it. And then inside the loop, I'm going to add I to total. So total plus equals I. All right, what did I do wrong?
I should equal 1, no?
It should equal 1, and what should it go up to?
11 or?
Yeah, it should go up to 11 or less than equal to 10. So, in this case, I'm going to make it less than or equal to 10. And it didn't ask for printing it out or anything, so that's enough.
What do you have on that for the auto grader?
I'm sorry, pardon me?
What would you have on there for the auto grader? Did you even put anything on there?
No, I
Just
can't.
curious.
Right. So write the include statement that lets us use file streams. Some of y'all put IOStream. Now technically that's correct. You have to use IOStream to get a file stream. But that's not the one that's specific to file streams. Fstream, right. And so # include Fstream. Now which data have we been using to open files for writing? If it's writing, it's output. You need OFStream. If it's in reading, it's input. So that one would be OFStream because it's for writing. And so the next one obviously is IFStream because it's for reading. It's input.
Did you have that set for IFStream or #include?
We don't need to # include OFStream. It's just that what data type is it? That's the class name. That's the class name. And I wouldn't have nuked you. I mean, if you have # include OFStream, did I give you any credit for it? It's not strictly correct, but at least you got the right class. Let me see.
No, I don't.
No, you don't have it up and running. Anyways, yeah. OFStream and IFStream are actually not separate header files. Once you get Fstream included, then OFStream and IFStream are classes within that header file. So you just do this, and then you can use OFStream and IFStream. But I would not have, probably would not have counted it wrong, or I would have given you 90% credit if you did # include OFStream.
Gotcha.
All right, so if we have a file stream named myFile, this will attempt to open the file and print an error message if it fails, true or false. Well, that looks pretty good to me. No. Yeah. Is there anything wrong with that, guys? I'm not seeing anything wrong with that. And you're saying, are you the prof? Who thinks that there's anything wrong with that? If it was Python, the syntax would be myFile equals open, but I believe this is correct. So if you have a variable named myFile, which one will write out to X? Okay, so we're writing, so it's just like cout, which means that the arrows have to go towards the variable. So it's not this one, because this would read in from myFile. It's not that one because the stream always has to be on the left side, can't be on the right side. That's wrong with that one too. And then here we go, my file, we're writing X out to my file, so D would be correct. A lot of people swap those two. Or actually a lot of people chose one of the ones that began with the variable name rather than the stream name. So here's the same question. We're gonna read from my file. Well, the stream has to come first, so that rules out that one and that one. And then if we're reading from it, then the arrows are going to go to the variable. And then how do we close my file? I believe it would be myfile.close. All right, somebody tell me, which one causes a loop to be interrupted so it bails out of the loop, jumping to the next statement following the loop? Yeah, break. Well, then guess what the next one's going to be. But anyways, which keyword causes it to be immediately repeated, skipping the rest of the code in the loop? That's continue. If it falls out of the loop, it's a break. If it jumps back to the top of the loop without doing the rest of it, it's a continue. All right, lots of people chose while for this one. And I know why you did it. A pretest loop that lets you blah, 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 blah. Well, we know what a pretest loop is. It's a while loop, so I'm going to choose for, and you don't get credit because this qualifies it to make a more specific kind of loop. If you get to specialize if you get to say the initialize, the test condition, and the update all in a single line, it's a for loop, right? I equals 0, I is less than 10, I plus plus. So this pretest one actually should have been a for loop, and I should have had like 4 different, choices down here. Like I said, I know why you chose that, because pretest means while, but for loops are also pretest. So the post-test loop is which? Do. And then a special value is a sentinel value. All right. Feel free to submit that if you want, or take it again on your own, whatever you want. All right, let's take a look at the next one. Chapter 6. And this is serving as review, by the way. That doesn't mean we're not going to have review on Thursday, but this is serving as review.
I thought this was on Thursday.
Pardon me?
I thought the test was on Thursday.
It is, and then I posted a notice. I hope that the notice is there. Since so many people hadn't done the Chapter 7 quiz, I booted the exam to next Tuesday. Let's make sure the notice is posted.
I believe it is. I saw some notes about it being moved to 11.
Is that homework still going to be due on Wednesday then?
Homework ought to be.
Okay.
Yeah. Okay, so open the frame in this tab. Alrighty, write a function prototype. So what's a prototype? It's just the function definition, but instead of having curly braces, it has a semicolon, and that's it. No body. So returns a double. We know that a lot of y'all got this right. Returns a double, so that's its return type. What's the name of it? Add 3. What are its variables? It has 3 parameters, double D1 and double D2 and double D3. So you just have to type that out. And since it's just a prototype, you don't do any body. You don't put curly braces or return statements or anything like that. Now if I asked you to write the function, then sure you'd do the rest of it. Every function must have a return type even if it doesn't return a value. That is true. If it doesn't return a value, what do you put as its return type?
Void.
Void, right.
Wait, what was number 1?
Oh, good question. Write a function prototype that has these. All right, its function name is gamma. It returns no value at all, so that makes it void. Who here knows what gamma is? Pink Floyd album. Alrighty. One of the quite obscure ones. Ummagumma. And what do I put inside the parentheses?
Double space.
Double D. And since, again, it's a prototype, just put a semicolon at the end. All right. True, false. The return type for a function that doesn't return a value is null. That's a false. It's void. And then, well, what do you know? A follow-up question. The return type for a function that doesn't return a value is void. Yep. Are these in the same order for y'all? I hope I didn't have these shuffled.
Yes.
Okay. Describe briefly what a prototype is and why you would use one. And then, you know, there's more than one way to write this kind of stuff. So a prototype is a function header or definition with no body. Why would you use one? Use one so that you don't have to put the function itself before where it is called. Something like that. I mean, you can word that more computer science-y than that. So don't feel stressed if you word it a little bit differently. You know, great. As long as you understand why you do it. You know, otherwise you have to put all your functions up above main. You have to make sure that they're all in the right order, right? And if you have two functions that call each other, which I guess is possible, then it'd be impossible to get that to work. So instead, you define your prototypes, and you usually stick them in a header so that you can bring #, include that header, get all the prototypes, and it doesn't matter where those functions are and in what order they are. Alrighty, so true or false, just like I said, prototypes should be placed near the top of the program or in a header file. Yeah, if you put them at the bottom, it's ridiculous, right? There's no reason to put a prototype at the bottom of the file. Match the term with its description. A value passed into a function is what? If you're passing it into the function, what is it?
Argument.
Yeah, it's an argument during the function call. That means that the variable in the function definition that holds, well, this looks like it's, is this English as mangled on your screen as it is on mine?
Yeah.
Yeah.
Okay. Anyways, 2. Alrighty, matching the description. If there's a star here in front of the parameter, is it a reference or a pointer?
Pointer.
That makes it a pointer. If it's an ampersand, that makes it a reference, and that means that the other one, the plain old ordinary one, is passed by value or passed by copy. Which of the following is true? More than one is true. All right, a return statement can be used to pass a value back to the code that called it. Sounds good to me. A function may have more than one return statement. A lot of people are tempted to say no. But no, you can put 20 return statements in there if you want. Good coding typically says you minimize the number of return statements so that it's not hard to figure out what the code is doing. But one common programming paradigm is that at the top of the function, you have error checking, right? If cannot open file, return false. If, you know, file name is bad, return false. And then you have some code there, and then you have another return statement at the bottom for if it succeeded. That's a common, you know, fail early, right? So that you don't get halfway into the loop before you figure out, you know. If you take it to heart, I should only have one return statement, and it has to be at the bottom of the code. Then yeah, maybe that's clearer, but maybe it's actually harder to read. You just have to try to figure that out. So that's fine. A function must include a return statement, even if it is declared as void. Well, if it is not declared as void, it has to have a return statement. But if it is, optional. So that's not true. And a function, wait. That's just the flip side of that one. Okay. Which of the following statements are true? I love telling people that 3 statements are true because then, they go nuts trying to figure out, well, I had only 2 true. Non-static local variables only exist. What? Is that what it looks like on your page?
Yep.
Okay. I wonder if I meant that to be true or false.
Well, seeing as how I didn't do that well on this quiz compared to the other ones, so.
Yeah. Well, that's why we're working on this together. Okay, let's go with the rest of them. Static local variables retain their contents between function calls. Now, we only talked about static local variables in one lecture, but you could hit your book for the definition of a static local variable. And the definition of a static local variable is one that retains its contents between function calls. Normal variables are wiped out, right? As soon as you leave the function, it's reset. Or it's lost, and then when you come back in, it's reinitialized. But a static local variable maintains its last state. So, that's true. And by the way, guys, I apologize for having garbage questions there. The scope of a global variable is the portion of the program from the variable declaration to the end of the CPP file. And that's true, right? If you declare a global variable above main, then every function declared after it, including main, can access it. If, again, like the prototype, if you declared your global variable down at the bottom of the code, it's not going to do any good. The local variable is available to every function in a CPP file. A lot of people check this one. And it's not true. It's local. What does that mean? It's inside a function. Global variables are available to every function in a CPP file, or at least from where it's declared down to the end. So that one's not true. A local variable is any variable defined outside all the functions of a program. Okay, what's the correct term here? Local is not correct. That's a global, so that one's not true. All right, and this one is. Unlike local variables, global variables are automatically initialized. And I don't know why they made the 2 behaviors different, right? Why did they make global variables get initialized if local variables do not? But this is true. And since I said 3 of them are true, we can assume that whatever this one was supposed to be has to be false. I wonder what I meant. Alrighty. Select the most correct statement. Bob. Is Bob a prototype?
No.
Nah, that's not right. Is Bob a global variable?
No.
Is it a default value?
Yes.
Yeah. A default value is one that's declared, or it's a default value for a parameter. So that's correct. And then lastly, is it an array? Nah. Oh, that's bad. Technically, it is an array. If anybody chose Bob is an array, you're correct, because something that begins with double quotes and ends with double quotes is a character array. Did anybody choose Bob is an array with that in mind? Wave your hand. Okay, good. I should remove that choice, though, because somebody could argue with me and say, yeah. Alrighty. Okay, go ahead and submit that as well. Hope that makes sense, and I hope that helped. So which questions were botched? $11 was botched. There was an earlier one botched too. Anybody remember it? That one. 8 and 11. All right, let's go fix them. You can help me write them. You're going, yay, I'm so excited. Alrighty. Now, to make a deal with you, if everybody gets the Chapter 7 quiz done by Thursday, we'll do the same thing for it. But if not, I'm not going to give you the answers if you haven't taken a quiz. So, all y'all got to do it to get the freebie answers. if it's not going to bring it up, then I'll fix it later. Yeah. Oh, there he is. Decided to cough it up. I'll fix it later. Not finding it as fast as I want. Alright, we should be done with chapter 7, since I'm making you take the quiz for it. I assume that to be true. Yep, because we talked about vectors. I don't think I put any questions about vectors in the assignment, in the quiz, which is probably implying that I'm not going to ask very many questions at all about it on the exam. I will have decided that by Thursday, and I will tell you. What is a vector? It's a data structure that grows and shrinks depending on how much data, as opposed to an array, which is fixed in length. And there are some methods for adding data onto it, push back. There are some methods for getting the value out, or you can just access it as though it were an array. Can't do that in Java. Wish you could. Can in Python, can in this language. That's pretty much all we need to know about it. I mean, really, if you're going to use arrays in the future, consider trying to implement them as vectors instead. You'll be better off for doing so, because the concept carries over into other languages, and it's nice to not have to worry about allocating a maximum length. Okay, so we are done with chapter 7. I feel like talking about static again. Static variable looks like this. So if I have this code and I call hello 3 times in a row, if this is not declared as static, and I forgot the data type, then what is it going to print? It's going to blip in here, x is set to 0, it adds 1 to x. I mean, heck, we could even do that right on its own line. And then it prints that x. So what's it going to print? Keep me awake, guys. Somebody say. Did I hear print a 1? Yeah. And then the second time, it runs back in here, it gets reset to 0 again, it prints out a 1 again. And the third time, comes back in here, it gets reset to 0. If we put the word static there, what it means is it gets initialized only once, and successive calls to the function do not reinitialize it. So, the first call blips into here, it's set to 0, we add 1 to it, we print it out, it prints 1, it returns. The second time we call it, it comes in. Well, since it's declared as static, it doesn't reinitialize it, so it still equals 1. Add 1 to it, print it out, so 2, and then 3. That's what static does. When you're doing you could achieve the same thing by making it a global variable. If you did this, then the code would work just as well. However, global variables are considered tacky. They're considered hard to maintain the code, is a better way to put it. If you're going to do something like that, it would be better to make it a static variable if it's not going to be shared among more than one function. The only reason to make a global variable is if it's going to be shared between more than one function. And honestly, by the time you're done with the class, you should be writing in terms of classes rather than functions, in which case you're not going to have any global variables. You will just make what were global variables into members of the class. Ooh, I don't even have the other PowerPoints available to us. Does that mean we have to go home? Nah.
Sounds good to me.
Alright guys, the recording was paused, sorry about that. Here's what we're doing. Just pause this and type it in or go and look at the notes. We're playing with a square structure. So we typed struct space square. By the way, you Java guys, there's no such thing as structures in that language. Pause it, type it in. Then we created two methods that accept squares as parameters. Pause it, type them in, whatever you want. And then down in main, we created two squares. Square S1, and then we set its height and its width. And square S2, we set its height and its width. So, let's call print square. Print square, parentheses S1. Print square, parentheses S2. And hopefully maybe it ought to work. Oh, my output's going to look lousy. I kind of forgot to do something after all these C outs. What should I do?
ENDL.
Yeah, I need an ENDL. Maybe on the next line or on the last one. And yes, I could put an ENDL on each one, but I'm trying to go for, just one line of output for every square. All right, there we go. I heard a sound that doesn't sound like here we. By default, all the members of a structure are public. I'm going to break the code now. And I'm going to make them private by doing this. Private colon. And by the way, you'd never do this. But it breaks the code. Height. We cannot access it. It's inaccessible because private. Private means that only functions that are part of that struct can access it. That sounds weird. Why would you put functions in a struct? Well, most people wouldn't. And I will make another statement that goes along with that. So that's kind of moronic. They default to being public. And that's good, right? Otherwise you wouldn't be able to change them. All right. So, although this statement is not strictly true, in spirit it is. A class is a struct with functions. So let's make a class. I think I'll scroll down here and just put it right above main. So what's this? This is going to be a triangle with a base and a height, just because I happen to know the formulas for calculating that area. So class, triangle with a capital T, an int base. I don't know why I'm making everything an int. Int height. So down here I'm going to make some triangles. Triangle T1. T1.base equals 10. And by the way, this is going to be syntax errors. T1.height equals 20. All right, that didn't work. When I said a triangle is a structure with functions, that's true. Then addendum to that would be whose items are all private by default. So if we want to be able to access them, we have to make them public, or we have to do something else. So to get this to work, I'd have to come up here and do public colon. For the Java students, note that in this language, you only have to put public or private one time, and then you can list a whole bunch of variables. But in Java, you have to put it before each one, right? This is what it would look like in Java. Nope, not in this one. Now you can. You could do this in this language. I want that one to be public. I want that one to be public. I don't see anything wrong in using that syntax. But honestly, you only need to put the word public until you're ready to change it.
Can you make one public and one private?
Yep, like we could make something, I don't know, a string name. Each triangle is going to have a name. Oops. Okay, let me fix it to the C++ way. I'm confusing myself. Whatever. So private variables are are variables that only functions inside the class can change. So the outside class cannot change it. If I went down here and I put t1.silly and I tried to set it to a value, that would be an error. Whoops, wrong place for it. So if I come down here, t1.silly is equal to 50, that's an error because it's declared as private. And you can keep flip-flopping. Public, lists 3 things, private, lists 4, public, private, public. Now, we don't need a silly member, so I'm going to get rid of that. So for our square, oh, you know what, that's moronic, isn't it? A square should have the height and the width be set to the same thing. Technically, what I came up with is a rectangle. I ought to do a search and replace. Control H, and the word square I'm going to replace with the word RECT for rectangle. And then I'm going to hit this little funny symbol over here, replace all. And yeah, you Mac users have to do it a different way. And if you don't feel like doing this, that's fine. All right. Okay, so notice that these functions here, get area and print rect, take a rectangle as a parameter, and they are defined outside of the structure. Well, we're going to write a get area and a print triangle functions, but they're going to be inside the class. So we're going to come up here and we're going to find our triangle class. I lost it, but here we go. So, int get area, parentheses in parentheses, and it's just a normal function definition, but it's inside the class. And if I want to be able to call it from outside the class, which I do because I want to call it from main, right? Then I better leave it as public. And so this is going to return base times height. But I want to show you a slightly different syntax. I'm going to delete the base times height, and I'm going to type return this dash arrow, dash greater than base, times this dash arrow height. That'll look different than you Java guys who've seen this dot base and this dot height, and I apologize for the difference between the two languages.
Divided by 2, right?
Correct, correct, divided by 2.
Can you do the weird arrow for the divide by 2?
Don't need to.
Okay.
I mean, like this, like that wouldn't make any sense.
Gotcha.
Because the 2 is not a part of the class, but base and height are.
Okay.
Now, in this case, this pointer is not strictly necessary. It knows that if I leave them out, that since these are not declared as local variables, then I have to refer to the class variables. When do you have to use this reference? If you have another variable in the function with the same name. Like if you do this, string base is equal to all your base is belong to us. Right, this is stupid, don't type this because I'm going to remove it. But anyways, okay, so I have a variable called base, it's a string, now I can't return base times height, right, because it thinks that base is a string. I have to convince it that the base that we want to use is the one that's part of the class. We want to use the base variable that is part of this object. So this dash greater than base times this dash greater than height. That's the only time it's mandatory. But it's kind of nice to be able to type this dash greater than and get a list of all the members, right? Because like if you have 20 members in your class and you use long variable names and long function names and stuff like that, it's nice to be able to do that. All right, how about a print triangle method? It doesn't need to return anything, so void print triangle, parentheses in parentheses. Notice that we're not passing in a triangle here. We did when we were writing squares or rectangles. We passed a rectangle in as a parameter. We don't need to, because this function is inside the triangle. It already has access to all the data, so we're not passing in a parameter. So these functions are part of the object. They already have access to the data that's declared. So, all right, so printing a triangle, how's about we go and find our print rect code and we do some copying and pasting. Because all we're going to have to do is change the word rect to triangle, right? So I found print rect. I'm going to copy that. I'm going to go back to print triangle, paste it, and change that one word to triangle. Oh, I'm going to wind up changing more than one word. I need to delete that SQ dot. Why? Because there's no SQ dot parameter, right? So I could just get rid of that. I could use this pointer. I could type this hyphen arrow height, or I could just delete the SQ entirely. Nothing wrong with doing that. Oh, but it's not called width. What is it called?
Base.
Base. All right. And get area doesn't accept any parameters? Okay, well, when I said we were not going to have to make any changes, apparently I was grossly over optimistic. We need to remove that. There. Now we are good to go. Why are you giving me grief? Why are you having a red arrow there? Red. Oh, get area. Needs to be capital A. And I would have known that if I had done this. Area less than this hyphen greater get area. Parentheses in parentheses like that. That's one reason it's nice to type this, you know, get a list of all the functions. Just make sure you put an uppercase A there if you get an error like I did. At least make it match that, whatever that is.
Right.
If you're having trouble maneuvering around in your code, and what I mean by that is if it's giving you errors, here's an example. If print triangle was in the wrong place, like that, all of a sudden it's going to say hyphen base and get area. That's because this function is not a part of the class, because it is defined after the closing brace of the class. One thing that is nice to do is put end triangle class, right? And by the way, difference for you Java guys, you don't put the semicolon in Java. In C++ you do. It wouldn't crash Java though if you put the semicolon there. Pretty sure that's true. All right, so we have a triangle. We said its base and its height. Now let's call print triangle. So t1 dot print triangle. Ta-da. Now I'm going to move one of my print rect statements up here. All I did is a little cut and paste. Don't stress about why. You don't need to make the change. Check the difference out here. For the structure, the functions that need the structure, we passed it in as an argument. For the class, sure, we could write some functions that took a class as a parameter, but normally what you do is you stick those functions inside the class, and then they have a special name. They're called methods. So this is a method. This is a method. A method is just a function that's declared as part of a class. Print rect is not a method because it's not inside a class. Functions that aren't part of classes or part of structures don't have special names. All right. All right, now, remember when I said that a class is a structure with functions? Ultimately, in this language, there's absolutely no difference between a class and a struct, except that structs, the defaults are public, and in classes, the defaults are private. I don't know why. Well, what happened is the struct keyword came from C, the C programming language. And then when C++ came around, they added a new keyword to create classes. And then to do the classes, they had to add some special features to it, right? They had to add the ideas of methods, and they had to add the ideas of private versus public. And then for some reason they decided, Mr. Jorn Structs, or however you say his name, that, okay, we're going to put all of that inside class as structs as well. So struct is identical to a class underneath it all, except for the default value of the members. In a structure, they're all public. In a class, they're all private. Now, in the real world, nobody adds functions to a structure. Because if you were going to attach functions to data, you would call it a class. But you can. It's just people will look at you very oddly. And in all the other languages you use, Python and Java and JavaScript and stuff like that, there is no struct keyword as far as I know. They're all classes. So struct is kind of an archaic thing brought from 1970 from the original definition of the C language. And you could do without them. You could make everything a class, never use struct. Your code would work just as well. However, there's zillions of lines of old-fashioned C code that is already written using structures, and the C++ compiler needs to be able to compile them, so they didn't remove the struct keyword from the language. Alrighty. So what is a class? A class, we could consider a class, let me just add some notes up here. A structure is a blueprint for a collection of data elements. A class is a blueprint for a collection of data elements and functions, parentheses methods, that act on that data. That doesn't mean it's mandatory. You could write a class that doesn't have data in it. All it's got is functions. That's legal. Or you could write a class that was only data, in which case it is effectively a structure. It's just like maybe you don't like structures because you don't use them in any other language. We could make a class that was identical to this rectangle. I'm going to do this, but don't bother. I'll undo it. I'm going to call it CRect for class rectangle. The only difference is I have to make it public, right? And then all of a sudden, I have a class that provides the identical functionality to the structure. So if I wanted to, I could delete that, and I could make this have the same name, and my code is not broken. Works the same way. Because classes and structures are identical, except that one has defaults of public and one has defaults of private. That's why I had to add that keyword there. All right, I'm going to undo those changes. I'm going to make this a struct as it was before. I could leave that public keyword there, but by default, all the elements of a structure are public. Why would you ever want to make anything private? The reason you make things private is it's called encapsulation. You can put some data elements in there, and then you can make them only accessible to the functions inside that. For example, our triangle class. What if we decided that it's illegal to have a base and a height that are equal or less than 0? Right? You can't create a triangle that's either 0 tall or negative tall or 0 width, negative width. We couldn't enforce that. There's no way to enforce that. If I come down here and I say T1 base is equal to -10, No problem. I say T1 dot height is equal to 0. No problem, right? There's no way to safeguard that data. What if I want to try to force it so that the state of the triangle is always valid? It's always got good data in it, meaning it's never got invalid data. It's never got 0 or negative data in it. Well, for one thing, we better have valid defaults. Right now, they default to 0, because just like global variables, variables inside a class and a structure default to 0. And I don't want that, so I'm going to set these guys equal to 1 so that they have valid values to begin with. But then I'm going to make them private. Private colon, int base equals 1, int height equals 1, and then the rest of this stuff needs to be public, because otherwise main will not be able to call get area or get triangle. So there we go. But that broke our code. Down in main, we can no longer access base and height. But we could create something that will set them. Let's write a setter for them. Void set base, parentheses, int base. And now I am going to use this pointer. This dash greater than base equals base. And I'm going to do the same thing for height. Void set height, int height. This height equals height. All right, now that doesn't solve our problem of main being a syntax error, but we can go and modify main now to use these two new functions. The colloquial term for these is setters. The fancy name for them is mutators. I hope the book uses that terminology. This is also a setter. That kind of implies that there's going to be a getter you could write as well, but this application does not require getters. So, do we have all of that? Are we ready to scroll down, or do I need to slow down? I don't hear any typing fingers, and nobody asked anything, so okay. Down here, where it says t1.base, we can no longer do that because base is private. But here's what we can do. t1.setBase 10. And t1.setHeight 20. That still hasn't fixed our problem. We can still pass in negative values or zeros or whatsoever, but we're real close to forbidding that. Here's how you would forbid it. You would go back and you would modify set base and set height so that they do not accept negative values or values less than 0, equal to or less than 0. So I'm going to scroll back up and I'm going to modify set base and set height to do that. Then you have to decide what's it going to do. Is it going to crash the program if they do that? Is it going to leave the values unchanged? Yeah, I'm going to make it leave the values unchanged. So anyways, I'm back up to set base inside the triangle class, and I'm going to do this. If, parentheses, base greater than 0, and then go to the next line, this base equals base. And I'm going to make the set height do the same thing. If, parentheses, height greater than 0, then this height equals height. So what's that saying is that if they pass in a value greater than 0, we're going to use it. If not, we're going to leave the value untouched. Now for our purposes here, why don't we print out an error message? Else, cout, quote, base must be greater than 0. \n. And add the same kind of thing for the if statement down underneath. Now, when we become more advanced programmers, we would probably do what's known as throwing an exception. And if you tried to set it to an invalid piece of data, the program would generate an exception, and your code would have to be able to handle the exception, or else it would crash. Now, that sounds bad. I don't think I'm writing code that's going to deliberately crash my program. Well, yeah, but you're forcing the programmer who's using your class, including yourself, to handle the case. Put code in there to handle it. All right, so else cout arrow arrow quote height must be greater than 0 \n. All right, now the code should be in a working state. I sure hope so, because I'm going to run it. All righty, and the base must be greater than 0, and the height must be greater than 0. And then when we printed the triangle, height is equal to 1, width is equal to 1, area is equal to 0. That sounds wrong. Did that ever work? Did the triangle calculation work before I made all these changes? It sure ain't working now, to use good English, huh? Alrighty. I need to go and look at get area. I don't get it. Oh, it's because 1 times 1 divided by 2 is 0. Let's make get area a double, so it can return a floating point type. And as a matter of fact, let's change all of our ints to doubles. Scroll up here and make int base equals 1. Make that double base is equal to 1, and double height is equal to 1. And then make get area return a double. What we're getting is floating point division, which rounds down. And so 1 times 1 divided by 2 is 0. I knew that was going to bite me, making these all ints. All right, there we go. If you have done that change, now, and you have negative values for the height and the width, triangle height is equal to 1, width is equal to 1, area is equal to 0.5, and I got some error messages, which is what I want. It is still a valid triangle. It doesn't have any invalid data, meaning that the basis that these values are not negative and they're not 0. That seems like a lot of trouble to go through. And if there's no qualifications you need to make for your data, then you don't need to make your data private, right? If there are no invalid values, great, right? But there can be invalid values. Like, what if you're creating a patient record, but the patient left off their name? Well, then you would make name private rather than public, so that if somebody didn't call the set function, then there would still be some kind of default value, or you would display an error message or something like that. This is called encapsulation, like you have a capsule. What is a capsule? It's, cellulose or whatever that outside stuff is, and it's got medicine on the inside. Or like M&M, the chocolate is encapsulated in a shell. So this data is encapsulated. It is kept safe so that these values cannot be set to invalid values. And that means one good thing about that is that I was able to change these internal data types from ints to doubles without changing any code down here. And that is ideal. The programmer who uses your class shouldn't have to know what these elements are, how the data is stored internally. These could be stored as 2 elements of an array. That would be ridiculous, right? But the base could be stored as the first element of an array, and the height could be stored as the second element of an array, for whatever purposes, I don't know. And then I decide to change that into some other thing. Well, the person using the class is just going to call set base and call set height, and they don't need to know how that data is stored. Why is that a good thing? Because what if you need to change it? Well, you don't want to make everybody who's using your class change your code just because you decided to change the format in which the data is stored. So by doing data encapsulation, you're protecting the programmer using the class, who is you, and that code from being too dependent upon the internal structure of that class and how the data is stored. Right? Maybe when you call set base, maybe it opens a file and writes the base out to it. Right? So that is about enough of the idea of classes for today. I keep mentioning the struct because I want you to have the idea But I'm not going to talk about structs anymore after this because you know how you're learning how to use classes now. Just remember that a struct is supposedly a class without methods. All right, let's stop there.